Check the sound again. Oh, that's pretty good. Right, we are doing calculus today. Where is my stream? All right, guys. If you're just joining, we're probably gonna start off at 8:00. What time should we start at? 8:04 a.m. We'll start. Hey, Stacy, welcome. If you guys are just jumping in, you're more than welcome to just start having a go at these questions. If not, what I'll do is I'll actually go through the answers at 8:04. Trying to think of Stacy, were you in the level 1 tutorial or the level 2 tutorial? I can't remember. I was level 2. It was last week. Yeah. My clock is just messed up at the moment. Where's everybody else coming from today? Got a nice small group. So guys, I was sent like 3 questions on Instagram earlier in the night, and kind of going to go through those 3 questions. I think they're all like merit or excellence questions, I would say. So yeah, we'll kind of go through that, and yeah, after that, if we've got any other time, we can actually work on other questions. How are you going, StarTech? Welcome on board. Have you guys, like, I know some of you guys are joining, and like, have you guys actually started calculus yet or finished calculus? What's happening in your classes at the moment? I know a couple of people have mentioned to me before that they've just started calculus this term. You guys are doing triple externals, so you guys are doing algebra, calculus, and probability. That's a lot. It's good fun. Malika, welcome back. So you're doing probability. So Malika, are you doing 3 externals as well? Are you doing algebra, calculus, and probability? Working on graphs internal, really? That's interesting. Made by Ben, welcome back. Yeah, it's always get the regulars coming on board. No, not a problem, Ben, because I mean, there's a few tutorials there for calculus, but I think the skills one, I was still kind of working on it slowly, and I just keep getting distracted. I think I've been getting distracted for 3 years now, so there you go. All right, and that's the case. I know, Kaye, you haven't actually done calculus. I'm not sure if you're going to sit calculus this year or not, because if you're doing graphs internal, I'm just trying to figure out how much time you've got before you hit calculus. But anyway, we are here, and we might as well get started with, let me just grab something. Copy link, where is this? Copy link. All right, we've got the tangent question first. All right, so what we're going to do, guys, is we're actually going to go through this tangent question first, which is, I will kind of take my time with it, all right? Like, so I kind of hope that if you do guys have like questions throughout the middle, you can kind of ask as well. But what I might also do is like, I might just take a little bit more time to explain to you guys what's happening to the question, so that you can kind of visualize the question first. I think once you visualize the question, it's it becomes just a little bit easier to kind of answer the question. So I will be kind of working on Desmos, so just give me a second. Where is it? Can't open that. Let me just see if I can just get this up and running in Desmos. So we're going to have a look at this question first, but I just want to show you guys what's happening with the question first so that it kind of makes sense. Because most of the times with calculus questions, it's better to kind of like draw the diagram just to kind of understand what's happening. Now, if you can't actually draw the diagram, then yes, you know, you kind of need to kind of have a guess what it looks like. So, all right, let's have a look. Y is equal to 6x minus 5. Right. Okay, so here we go. We'll try and do this question at the moment. Let me see if I can switch cam. Where is this? Desktop with camera, is that it? Yes, okay, so let's go back to this thing right here. So what we've got here is we've got a line that's a tangent to the curve. We've got a point P lies on the curve so that the tangent is parallel to this, blah, blah, blah. Use calculus to find P. All right, so let's go here. The red curve that you guys see right now, let me just make it a little bit better so we can kind of see what's happening here. Y, no, I'm going to keep that 25. But X, I want to change X to about maybe 5. And change this to about -2. Okay, here we go. All right, so as you guys can see, what's happening here is the red is the curve right now, and we've got this tangent, which is 6x minus 5. Obviously the tangent is kind of like, you know, the gradient is 6. Because the gradient is 6, along that point right there, when x equals to 3, is when the gradient is 6. Now, if you go back to the question's actually asking another point P lies on the curve. So if I go back to here, we are going to get, let me just change this. So we're going to get P is, I'm going to see if I can try and put this x comma f of x. Is that going to work? I haven't got this sussed out yet. Nope, that's not going to work. So basically what I'm looking for is a point where the gradient is parallel to this blue line, right? So if it's parallel to the blue line, what we know is that we've actually got another equation which has the same gradient because they're parallel, but what we don't know is its y, like the y-intercept. So as you can kind of see, if I kind of try and map it, you can kind of see that somewhere around there it has got a gradient of 6. But you know, I mean, visually we can see what's happening, but we've got to try and prove this with what do you call it? We got to try and prove this with calculus. So what we're going to do is we're actually going to try and figure this out. So that's what we're trying to do. Let me just go back to the questions. Yeah, no questions there. Did that kind of make sense, guys, what I was trying to show in the diagram here? So basically, I mean, visually we can see that the p-value is going to be 1,9. Like we kind of know that that's the point that's going to be, but we have to kind of prove it using calculus, right? But I guess I just wanted to show you guys what's happening here. So this is the original point that we had where the gradient is 6. Then this 1,9 is the point P where the gradient is also 6, but it's because it's parallel, right? So if it's parallel, the gradients have to be the same. So we actually have figured out what the answer is just by like plotting it on Desmos, but we have to now prove it using calculus, and that's what we're going to do. Hopefully that made sense. So here is how we go about doing this question. Let me just move a couple of things. So the first thing to kind of break down is that we have f of x, which equals to 2x cubed minus 12x squared plus 24x minus 5. What we're going to do is we're actually going to differentiate this. And I think this would, most of the time with calculus, you've got to kind of differentiate the function. So we're going to differentiate this. And what we're going to end up with, f dash of x is equal to 6x squared minus 24x plus 24. All right, so this is what the gradient function is. Now, once we've got the gradient function, our next step is then to go, okay, so this is the gradient function. I want to know what's the values of x where the gradient is equal to 6. Now, with our, and that's what we did here. We've already figured out where the gradient is 6. The gradient is 6 when x equals to 3 and when x equals to 1, but we actually need to prove it. So we're going to go back to our function here, and we're going to put down f dash of x is equal to 6. And the reason I got the 6 is because the 6 is actually from here, where it says the line 6x minus 5 is the tangent. So that's the gradient. So m, or gradient, is equal to 6. So that's where I got the 6 from. Once I got that 6, I can write this as 6 equals 6x squared minus 24x plus 24. Now at this point I've got 6 as a common factor, which I can take out, and I'm going to get x squared minus 4x plus 4. Just trying to see if I've done this correctly. What am I missing here? Have I copied the question wrong? No, I've not copied the question wrong. No, that's all fine. Cool. So the next thing is I'm going to take this little x, this little 6 across, and I'm going to get 6 divided by 6 is equal to x squared minus 4x plus 4. So I've got 1 equals x squared minus 4x plus 4. And if I rearrange it now, I'm going to get 0 equals x squared minus 4x plus 4. And of course, this is going to become minus 1. So I've got this nice little quadratic, which is x squared minus 4x plus 3. So at this point, I can factorize this, where I'm going to get x minus 3, x minus 1, and therefore I can say that x equals to 3 or positive 1. So what we've really done here is we've kind of just gone back and figured out that we've actually proved how we get x equals to 1 and 3. So if you guys go back here, we've just shown them that when x equals to 1, the gradient is 6, and also when x equals to 3, which is right about there, the gradient is also equal to 6. Now, is there any questions from that? So for now, before I actually move on, let me know if you guys are okay with that, and then we can actually move on to the second part of this question. Okay, quiet means I'm going to keep carrying on. Cool, so now that we've got x equals to 1 and 3, what we need to know is the y value itself. So we're going to go back and we're going to put down f of 1. So the original function, which is 2x cubed, so 2 1 cubed minus 12 1 squared plus 24 times 1 minus 5. So when we do that, we're going to get 2 minus 12 plus 24 minus 5. So we've got 26 take away 17, which equals to 9. And there's our first point, which happens to be 1, 9. Then we repeat the process again for f of 3. So we're going to get 2, 3 to the power of 3 minus 12 times 3 squared plus 24 times 3 minus 5. I'm just going to use the calculator for that. So 2 times 3 cubed, 927. 2 times 27 minus 12 times 9 plus 72 minus 5, and that's going to give me 13. All right, so here is my second point, which is 313. So if we have a look at, I'm just going to go into comment section just to see if there's anything else there. Why did you divide it by 6? The reason I divided by 6 was because 6 was getting multiplied with that bracket. So that's why I divided by 6. I mean, alternatively, you could have done it the other way as well, where you could have brought minus 6 to the other side. And then you could have kind of worked it out. Do you have anything to do with the minus 5? Not sure, Ben, because the minus 5 just gets added up all together. Because negative 12, negative 5 is negative 17. Since P is parallel to Y. Right, Stacy, no. Look, when the point P is actually lying on another, like let me show you what the next part of it, right? So the next part of it is like, because we've got 2 points right now. We've got 1, 9 and we've got 3, 13. Now, one of these points actually lie on the line 6x minus 5. So if you look at it, first one we have is 6x minus 5. So if I actually substitute, if I put x equals to 1 in this, I'm going to get 1, 9, which is going to give me, why am I getting 1, 9? Hang on, give me a second. Just want to go back to this. It's a tangent at the point 3, not 1, 9. So yeah, actually it doesn't work. So let me go back to this. So if I put x equals to 1, I'm going to get 6 minus 5, which actually gives me 1. But then if I put x equals to 3, then I'm going to get y is equal to 6 times 3 minus 5. 6 times 3 minus 5. It's going to give me 18 minus 5, which equals to 13. So you can kind of see that 313 actually lies on that 6x minus 5. And because of that, then we can actually say that P is equal to 1, 9. Let me just pull this up. Give me 1 second, guys. I just need to rearrange a couple of windows so I can kind of see what questions are coming through. All right, let's go back to this. And I want this window up here. Okay, so what I did was this blue line here. So I'm going to answer Stacy's question. So the blue line is the original line, which is 6x minus 5. But the point P is this one, right? The 1, 9 is point P. All right, because what we're trying to do is we're trying to say at point P, the gradient is equal to 6. All right, and the way we know that the gradient is equal to 6 is because in the question they actually say that it's actually parallel. When two lines are parallel, when their gradients are actually equal to each other. So in this case, I found out that, okay, so this is my original point that I had, which I didn't know what it was, but all I knew was it had a gradient of 6 in it. And because it had a gradient of 6 in it, I put it into my gradient function, which is actually here. And I put down my gradient function is equal to 6 to figure out the two x values where the gradient is actually equal to 6. So, and if I go back to my little Desmos diagram, you can see that at 1 and when x equals to 3, that's when the gradient, the slope, is at a 6. Once I grabbed those points, I needed to test out which one of those points was actually lying on the blue line. So for the blue line, this is the test that I had to do. So when I put x equals to 1, I actually got y equals to 1. And that doesn't actually work because that point is actually not on the curve. Let me show you how, because this point right now I've got 1, 1. So if I go back to, I'm just going to put a point 1, 1 here so you can kind of see what's happening. point, and then I'm going to call this P, which is going to be all right. Let's try this one here. So as you guys can see, that 1, 1 is the other point. It still lies on the blue line, but it's actually not on the curve. But 313, which happens to be right here, so this is going to be 313. So 313 already is on the blue line, which is the 6x minus 5, and it's also on the curve itself. But then when your other gradient is 6, that's where P is, and that's the point we figured out to be 1, 9. Let me know if that made sense. Otherwise, we can do another question like that, similar to it, so you guys kind of get the hang of it. I'll go back to the notes, by the way. All right, you good? Okay. Yeah, it's basically just kind of, where are we at? Yeah, it's basically just matching up your gradients and then trying to work out what the x values are, and then from there trying to work out which point actually is the correct point. So, okay, I know it was a bit a lot to take on, but that is, yeah, it's, I think that's a merit or an excellence question. I'm not sure. It might be an excellence question actually, just because you have to kind of go back and explain why that, how that 0.19 is actually P. Shall we head on to the next question? What do you guys want to do? Malika, don't actually go near probability at all. It's just way too much for me to try and do all of that as well. So I kind of stick to mainly to algebra and calculus. I've done some probability, but not enough to kind of do questions on the spot. It's just like, yeah, never do it. It depends on your strengths, Stacy. I mean, like, how do you how do I put this? Do you need to kind of revise all the skills again for algebra, or do you want a combination of like skills and exam questions? Because I've got two separate playlists. One is primarily focused on just skills. One is what I do is like for the it's a kind of like a hidden little playlist within my channel, but I did this during the first lockdown pandemic back in 2020. There's about 13 videos, and what it does is basically I go through a skill, and then we actually end up doing a lot of exam questions for the, I think we spend about 20 minutes doing skill questions, and then we just do exam questions after that. And I think people that have watched it have come back and said that they have found it quite useful. So I can see if I can try and if I can find it. It's kind of hidden in my channel under playlist, but let me just see if I can find it. Where is it? Mathematic level 2. Just give me 1 second here. That was session 1. I think was it session 2 I started doing algebra. Right, okay, so I'll put the playlist up here for you, which I really need to rename it as the one Stacy I need, the one playlist that you need. Okay, so here you go. So this is the playlist. Watch it from episode 2 or like video 2. There is 12 videos that you can watch. They're all like nice long 1 hour videos, all right? So I think even if you spend like 1 day watching them, and because I do a lot of questions with you, it's super handy to kind of put that. I've been told that it's been really helpful, those particular videos that I did back during the lockdown. Yeah, they are a bit of yeah, they do cover a lot of algebra stuff and like a lot of exam questions. So I think that's what I'd recommend for you to do. Hey, Ryan, welcome, man. How you going? All right, guys. So we've got this next question, which is a good old kinematics question. I'll tell you what, I'm going to give you guys a couple of minutes to maybe try and do at least some of it. And then after that, I'll actually go through the answer in full as well. But on the other hand, just give me a yell out if you need any other questions answered as well. Otherwise, we'll go through this answer in about a couple of minutes. Again, the reason I'm kind of focusing on these big excellence questions is that those were the only kind of like, I had 5 questions sent to me, but they were all big questions. And I would rather kind of explain. I mean, I know for me just to do the answer real quickly, it takes about 5 to 10 minutes. But when I actually show you guys, spend a bit more time on that question, you really understand what's happening. And of course, I'm going to give you guys time to kind of ask questions and get those ideas cleared out. Welcome, FaZe. How's it going? Jabok, UFC atomic and nuclear test coming up. Unfortunately, no, man. Like I did physics back in '99. That was like such a long time ago. So I don't even remember doing anything atomic or nuclear. All I remember doing was like a couple of formulas that I kind of scraped through because I knew how the formulas worked. I had no idea of how physics worked, but I knew how to rearrange formulas to get the answer. All right, guys, so what shall we do? Let's go through this question, all right? Let me just pull up. So with kinematics, some water. Kinematics, acceleration, velocity, and displacement. So what have we got is this. The first thing we've got acceleration. Our acceleration equation is equal to 60 minus 10. What are we trying to figure out? We are trying to figure out object is moving in a straight line through a fixed point P. When the object passes through P, it's traveling at 3 meters per second. Okay, that doesn't... Okay, fine. We'll call it P. The acceleration of the object is given after the object first passes through P. Okay, whatever. Use calculus to find the distance between 2 points when the object is at rest. Okay, so the key word that we're looking for is object is at rest. Now, with kinematics, what they tend to do is like they have these certain words that they use, right? And one of them is rest. So with rest, what it generally means is that your velocity is actually zero. So we're going to put down velocity is equal to 0. And also, there's actually 2 points when velocity is equal to 0, because it actually says that in the question, right? So because of that, we've got to actually figure out what our velocity function is, put it equal to 0, and then kind of work through. So to get velocity, we're going to integrate, or anti-differentiate as some people like to call it. We're going to integrate 60 minus 10, which means we're going to get 6t squared over 2 minus 10t plus c. So this is what we're going to get, right? So at this point, we can kind of rewrite this as 3t squared minus 10t plus c. Now this is what velocity is going to equal. The other thing that we can kind of assume here, it says when the it actually says the object is moving through a straight line through a fixed point P. So I might actually, I could actually kind of go around and say that, you know what, I'm going to choose P as my 0 value, like, right? So I'm going to put that down. I'm going to put, when, for P, I'm going to put down t is actually equal to 0. So that's the point P. If that's the case, I want to know what the velocity is when t is equal to 0. But it actually says that, right? At P, so at point P, we can say the time is equal to 0, but the velocity is equal to 3. And the reason why we say all of this is because we actually have that here. So because of that, I could actually go down here and put down 3 is equal to 3 times 0 squared minus 10 times 0 plus c, which means I'm going to get c is equal to 3. So what this tells me is my velocity function is equal to 3t squared minus 10t plus 3. So while this is my velocity function, I need to find out at what times is the velocity equal to 0. So I'm going to put down 0 equals to 3t squared minus 10t plus 3. Now, you're sitting there going, it's like, oh man, I don't want to sit there factorizing this. Of course, you don't have to factorize it, because all you got to do is just make sure you have a graphics calculator and go into equation. Chuck in your polynomial degree 2, and we're going to punch in these values, which is 3, minus 10, and positive 3. So when we do this, we're actually getting two values here. We've actually got t is equal to 3 and t is equal to 1/3. So we're going to put that down. T is equal to 1/3 and t is also equal to 3. So what we've just discovered is the two times when the velocity equals to 0. All right, so this is what we've done so far. Now our next bit is to try and actually work out what the distances, or the displacement, as sometimes we like to call it too. So we're going to actually anti-differentiate or integrate the velocity function. The velocity function is 3t squared minus 10t plus 3. So if I integrate this, I'm going to get 3t cubed over 3 minus 10t squared over 2 plus 3t. Now all of this could be, and of course I'm going to have that plus c, and we're going to put this as t cubed minus 5t squared plus 3t plus c. Now here's one important thing about the s in this case though, because in this particular case we're looking at the distance from P where t is equal to 0, and so because we're measuring distance, we could almost kind of put that as 0, because we just want to know the distance. Like, we want to know what was the distance at 1/3 and 3. So we can, it's kind of like working with relativity. Like, you can kind of just go, right, because the distance is like relative of how far I move, at point P, I can almost say that, okay, my distance function is just going to be t cubed minus 5t squared plus 3t, because at 0 we're going to say the distance is 0, and that's why we can kind of like ignore what the c is. So the next step is I need to work out what s of 1/3 is, and I've also got to work out what s of 3 is. So with s of 1/3, I've got 1/3 cubed minus 5 times 1/3 squared plus 3 times 1/3. And as for the 3, I've got 3 cubed minus 5 times 3 squared plus 3t, which is times 3. So I've got to kind of work out these two things. Now I know a few weeks ago I kind of was playing around with some alphabets, with storing letters and kind of working it out. I'm going to try and do it this time to see if it actually works. If I go 3 alpha, let's go E. Okay, all I've done is I've actually stored E as 3, and because I'm so lazy, I'm just going to do this. I mean, I go alpha to the power of E to the power of 3 minus phi alpha E squared plus 3 times alpha E. So when I do this, I actually get minus 9. So I'm going to write down minus 9. Now, I want to substitute 1/3 in it. So what I'm going to do is I'm going to put down 1/3 as a fraction, and I'm going to change E as 1/3. There we go. And then what I could do is I could go back press up, and this should now, because E is being substituted as 1/3, it's going to give me my next value, which happens to be this. Although it doesn't seem right. I don't know why. Did I get -9? Yeah, I did get -9. No, that's fine. So I've got 0.48 for this one. So then I can say that the distance between two of these points is going to be, well, one is at -9, and the other one is at 0.48. And because it's kind of like, how do I put it? It's the minus is because it's actually gone back 9, right? So it's gone back 9, and then it's still 0.48 positive on this side. So if you look at the total distance, you're actually looking at total distance of 9.48. So that's what you're looking at for this particular question. Now look, I know there's probably quite a few questions here. So what I'm going to do is I'm just going to put like a whole bunch of lines, numbers. Let's go 6, 7, 8, 9. So if you guys don't get any kind of particular line number, you can just yell out and I will explain to you. Oh, I don't get why we have to add the -9 and 0.48. That's a really good question, Stacy, because it is. So if you think about it like this, right? Imagine the scale is like this. And let's say this is equal to t is equal to 0, right? So if that's the case, when, like, what we're going to do is, I'm going to rewrite this as s, actually, just to kind of make sense. When t is equal to 0, the s is like 0. But when it's 1/3, this is s of 1/3, which actually is positive 0.48. But if you look at the s of 3, it's somewhere back here where it's actually -9. And what we're looking at is the distance between these 2 points here. And if you remember, like that was the reason why we actually add +9, because distance, the -9 is the position of it from that center, from the middle, which is 0. But if we look at it as a unit, it's actually 9 units long. So on the negative side, it's actually, the yellow part is actually worth 9 units, and the green part is actually worth 0.48 units. So when you add them up, you actually get 9.48. That's why you kind of have to add it up. You're not looking at, you're looking at the actual distance and not the position. So it's kind of like this. Imagine like if I have a x and y axis, right? And I say that this is going to be +4 and this is going to be -3. So if I have a point between these 2 points here, and if I ask you, what is the distance between these 2 points, you won't actually say it's 1, because you don't actually go 4 - 3 is equal to 1, therefore the distance is 1. That's not how it works. How it works is that you'd actually go, well, from here to where the x-axis is, that's 4 units. Then from the x-axis to the point itself is another 3 units. So which means totally the distance between those 2 points is actually 7. And that's what we're trying to do here in this case with the -9 and the 0.48. I'm hoping that made some sense, Stacy. Let me know if you still have any questions. All right, okay, so glad that could kind of work out. Let me know, guys, if there's any other questions with those numbers, any numbered lines that doesn't make sense. Otherwise, what we'll do is we'll go to the last question for the day. Again, I think these questions they'll all be excellent questions. And even if you guys can actually kind of do it to a particular point, you're going to get like, you're probably getting a merit or an achieved quite easily by just integrating it. And doing a few substitutions here and there. All right, should we move on to the next question? Or we had a lot of talk about mechanics. Lovely. All right, let's go to the last question here, guys. Today's last question is this one here. Kind of put that there. So what I'll do is I will kind of leave you guys a couple of minutes to kind of have a crack at it. Yeah, let's just see how you guys go with this. It is one of the more slightly trickier question in terms of like excellence questions that I've seen, but it's actually not too bad. I mean, you will understand it straight away once I kind of start explaining it. You'll be like, oh, that wasn't really that hard. But see if you can have a kind of play around with it. I'll go through the answer at about 8:45. All right, let's see. All right, how are we going, guys? Good, 8:45. Another minute, all right, and then we'll go through this. Okay, guys, so let's give a crack at this question here. Now, this question is not your traditional kind of calculus question, right? Because what they've actually done here is they've kind of did a little bit of trick with it, which is they want to know what the maximum distance between the line and the parabola is. So imagine it like this. What they're really asking you is they want you to prove that this this green line is 1 over 4a, because that's pretty much what they're trying to ask you here, right? Now, there's no other information that's actually given to you guys, apart from you've got a straight line, and then you've got a parabola. But imagine it like this, right? What I'm going to do is I am going to open up another Desmos graph just to kind of show you guys what the question is actually asking. So we're going to go y equals to x squared, and then we're going to go y equals to x. No, not x. Maybe 3x. No, let's go 5x. Okay, so what I'll do is I'll show you guys what this kind of thing is asking, right? So I've just put two kind of graphs here. Now, if you look at this particular graph, right, you can go, well, at this point, the y value is 5, and at this point, the y value is 1. So we can kind of count it. We can see it's like, okay, so the distance between here and here is about 4. The distance between here and here is probably like less than 3. No, just about 3. But what the question's actually asking is, what's the maximum distance between these two lines? Well, if you think about it, what are we doing here? We're actually looking at the y value, which is 5, and we went minus the y value of the blue one, which is 1. So 5 minus 1 is 4. So really, we've just got the y value, take away the y value from the parabola. So if that's the case, then for this one, I could actually say, well, if I actually take the straight line, the y value of the straight line minus the parabola, it's going to give me the distance between the two graphs. So basically the green part of it is the straight line's y value minus the parabola y value is going to give me that. But really, we already know what that is, because that's just the straight line's equation is x, and the parabola's equation is ax squared. That's pretty much our equation. All right, now what we do with calculus is that we got to differentiate this function, put it equal to 0, and we're going to get the x value of when the maximum actually happens. And then I'm going to show you guys the shortcut of how to show that it's actually a maximum as well. So if we call this, I don't know, height. So the height is equal to x minus ax squared. So if I differentiate it, I'm going to get 1 minus 2ax. And I know that the maximum actually happens when the gradient is equal to 0, right? So I'm going to put down h dash is equal to 0. So 0 is equal to 1 minus 2ax. Rearrange it, I'm going to get positive 2ax. Because when I switch it over to the other side, it's going to become positive. 2ax equals to 1. And then I can say that x is equal to 1 over 2a. So all I've done here is I've actually told you guys what the x value is when the maximum actually happens. So if we go back into the original equation of the height, which is x minus ax squared, and I'm going to substitute 1 over 2a. So I'm basically finding out what h of 1 over 2a is. So I'm going to get 1 over 2a minus a times 1 over 2a squared. So doing this, I'm going to get 1 over 2a minus a times 1 over, what is my area actually coming up to be? 1 over 4a. All right, so if I do that, I'm actually going to get 1 squared is 1, 2a squared is going to be 4a. I got everything right here so far. Let me just check. Always seem to be like a bit missed question here or not. Let me just check. Where am I missing the ax squared? 4a squared. There we go. There's my mistake. Thank you very much. Did anybody pick that up? No, nobody picked that up. I'll just finish this quickly and then I'm going to come back and answer that question, Stacy. So here I'm going to get 1 over 2a minus 4a. So your question was, how did you derive that straight parabola, and isn't the vertical height from the x-axis upwards? How did you derive that straight minus parabola y? So the reason I derived because the original function of h, Stacy, is actually it's between the straight line and the parabola, right? So when I actually get some values and I substitute it in whatever the x value is, it's actually going to give me what the actual height, the green height is. So I've literally written a formula for the green height. So this h equals x minus ax squared is the distance of the green line. Now, if you think about it like this, the yellow line is what x is. So that's the straight line. And if I take the blue line, which is the parabola, that is actually the ax squared part. So what I'm really trying to do is I'm trying to figure out the gap between the yellow and the blue. Because the gap between the yellow and blue is going to give me the green, which is the actual height. And that's the equation I need to differentiate, because my question is actually asking what is the maximum vertical height. The vertical height, yes, you're right, it is from the x-axis upwards, vertical height. But if you think about it, the green line that I've highlighted here is the vertical height, between the difference between the two graphs. Let me know if that makes sense, or if you still have any questions. Happy to answer before we kind of move on. I'll keep an eye on this while I just kind of carry on with this question here. So because 2a, did you just use a times 2 for the parabola? Oh, yeah. So because, are you talking about the ax squared to the 2ax? Is that what you're asking about? Yes, that's what I did. Because if you go back, it actually says that, right? Like, look, where does it say? The vertical distance between the line fx is equal to x, and the parabola, that's the parabola's equation. It's actually been given right there. Yeah, that's how I knew that ax squared for the parabola and x for the straight line, because it was actually given in the question. that bright light right there, it's like that's cool. That's cool. All right, let's keep going. So we've got 1 over 2a. I need to have the same denominator. So what I'm going to do is I'm going to multiply by 2 in the numerator and 2 in the denominator, which means I am going to get 2 over 4a minus 1 over 4a, and this is going to equal 1 over 4a. Now, if you guys notice, that is what was given originally. I know it's a bit tiny there, but I'm going to kind of zoom in so we can have a look. It said justify that 1 over 4a is maximum vertical length. What we've done is we've actually proven that it's 1 over 4a, but we now need to justify. So we actually need to do a double derivative. Double derivative is my favorite one. Like, you differentiate it twice and then substitute the value to prove that it's a negative or a positive, and you're pretty much good to go. So if you look at double differentiation, h dash is equal to 1 minus 2ax. So h double dash is equal to negative 2a. All right. Now here is the important part. One of the clues that the question actually gives you is this right here, where it says a is positive. Now remember, if you have a positive number multiplied with a negative number, you're always going to get a negative number. And so what you can actually say is h double dash is always negative because a is positive. And you don't need to justify it, but you can, and you can say and negative multiplied by positive is always negative. Now you can say, therefore h double dash is less than 0, therefore h is the height is max. So this is like your, I don't know, like some teachers don't actually teach double differentiation. Some people like to look at what's happening to the curve before and after. I prefer going with double differentiation because it's easy. It's you kind of go, right, oh yeah, it's like double differentiation. When I differentiate it twice, if it's negative, it's a max. If it's positive, it's a minimum. So you kind of go, that's all you need to do. So I would I think I have done some videos on double differentiation before. So if you guys have a look at it, yeah, I would actually say go with double differentiation. It's a lot more easier than trying to look at oh, sorry, I made a mistake. Negative, positive, sorry. Thank you for picking that error up. It should be negative, and positive is always negative. Thanks, Stacy. Yeah, getting late in the night. So yeah, another it's a really good excellence question. It just kind of stretches your thinking but when you think about the actual working of this, it's actually quite, it's pretty straightforward, but it's just that first part where you actually have to come up with that equation. And again, when you guys do more of these types of the more excellence questions, what happens is that you tend to kind of find, when you see these questions with achieved in merit, you kind of go, oh yeah, that's pretty straightforward. I can just kind of do that straight away. Right, that's pretty much it for us guys today for those 3 questions. What I'll do is, as always, I'll just hang around for a few minutes. If you have any other random questions time, feel free to ask away. Otherwise, I will catch you guys next week. And yeah, just send me questions. If you send me questions, then it's easy for me to kind of sit there answering them through the night. We can take our time exploring it, so it's not rushed, and you can understand, you can ask some really good questions. You're welcome, Stacy. Hope that helped. Quiet day today. Quiet day. That's all right. I did ask some of my my students to come, but they're like, oh, year 8s. This is no, year 9s. It's probably way too ahead for them. All right, quiet time it is. All right, guys, if there's nothing else, I will catch you guys later. Have a good one, and I'll see you guys in about 1 week time. And as always, if you do have any questions during the week, just feel free to send them to me. What school do I teach at? I teach at Ormiston Junior College. I actually teach year 8, 9 maths. I think I enjoy teaching this stuff. I actually enjoy doing, the NCEA level maths, algebra, calculus. I enjoy doing it, but just get so sick and tired of marking. But this is nice. I can just kind of do my thing and then let you guys go off, and your teachers can actually mark. Yeah, the highest maths I teach in class right now is year 9 maths. I'll just show you some of the work I do, but nah, it's alright. Alright, no other questions. Guys, take it easy. I'm gonna go watch some TV. I will catch you guys next time. Alright. Stay safe till then.